it going? Just got to do some housekeeping. Just make sure we're doing them. Make sure we're streaming. Let's see if we're streaming. Doesn't look like we are. What have I done wrong? Right. Well. Don't know. Unless it hasn't quite caught up yet. Oh yeah, we're doing it now. It hadn't quite caught up. Right. Let's just lower the res. Don't want to tie up all the bandwidth. Got audio? Don't know. Yeah, we've got audio. Right. Okay. Welcome everyone to another What's So Good About an Arduino? Anyway. 2. Right. See you in a few seconds after the intro. Here we go. Ready? Got to do some housekeeping. So we're going to be doing a bit more code. A bit more of this here. Something else. Arduino. Okay. See you in a few seconds. Howdy everyone. Right, I'm a bit late tonight because I've just been doing an annual video. It took me about 3 or 4, maybe 4 or 5 hours just to put a video together. There's not much to it, but anyway. Right, so what are we going to do today? So, if you haven't watched the other episode, maybe start watching that one first. So I've got a new thing here. Not many people have responded to this first video. This is the second one. So probably I'm not putting the information down right, or it's a bit ad hoc. It's ad hoc, so I don't know what I'm going to do until I do it. It's nothing scripted. There's no scripted. Got a basic idea of a concept and that's it. So I can't really tell you what it is before it happens because I don't know yet myself. Anyway, so what's so good about an Arduino anyway? Right? I don't even know who said it was good, but anyway. So this is number 2. Let's just go back to the code and see what we're going to add to it. Right, so we've got this again. We're still all plugged in. Just go through it. Yesterday, I think it was yesterday, yeah. We started with a blank sketch. Blank Arduino sketch. We've gone back to the Arduino IDE just to make it simple. Right. And I'll just say hello to everyone. Hi everyone. Let's say welcome. Welcome. Join in by all means. There you go. Okay. Right. Yes. Right. Okay. So what we're going to do now? Let's have a think. So yesterday we did what did we do? We set up a function to execute every 1 second, and we even put in we did a serial print, conditional serial print for debug levels. Debug level 1, you got no debug, function name only, function name with first parameter, function name with second parameter. So we've got ourselves a struct set up, which we can use it to select use serial, provide that parameter to use serial, and then we get different information based off it. Okay. Anyway, let's see what else we can do now. I've got a bit of a blank, but anyway, let's see what else we can do. Let's just check on that. Yeah, we're okay. Right. Oh my god. Okay. The next problem. Hi Dave. What are we going to? I can't see that. The heart's in the way. What are we going to do? Can you shortly explain? Yeah. Okay. I try, but what it is, we just got. I don't know whether you watched the last one, but what we got is we've just got one of these gadgets. Hang on, let me just switch back to the. I'm trying to monitor the thing as well. Hang on. Yeah, so we've got this ESP 32S3. We've got one wired up. There's nothing. It's just plugged in, and we're just running the Arduino IDE, and we're just basically. I wrote a lot of code over the years, and I found a few things out. And basically, I'm just trying to share anything that will make it easier to develop stuff. It's alright on a small sketch, but I've basically done stuff with the sketch. When they show you all the examples, they show you a single page or a few tabs, and that's it. I don't know if people are aware what you can do firmware-wise, with it. So we use Visual Studio Code. We're compiling for different controllers. I've got massive amounts of stuff. So some of the stuff that helped me develop to that level, to be able to keep track of it, if you're not careful, you'll end up in a big mess. So I've got certain ways of doing stuff, like I create this struct, for instance. This might seem like a waste of memory, but we declare this static constant byte, and we give them a constant value. You can do it with an enum, but I've just found enum. It's I just prefer this method. So you type def as struct, and you basically select your debug level. I mean, whatever your struct's going to do. So, but you can extend this to all sorts of stuff in your program. If I just open up for my main code, I'm using Visual Studio Code with Platform IO. But in here, once you've got massive amounts of code, you could get lost easy in it. I still get lost now. Yeah, so you get lost now. So going back over it, I've just got to keep switching back and forth. Right, okay. I could do with another monitor, actually. I might have to get another monitor set up. Right, so Platform we're compiling for different controllers, and we can switch whichever one we want on. And the code, it's quite huge. Like this code is just for the firmware. So the source on it starts from this one here, access groups, and it goes all the way down, all this lot, and down to there. And the only real way you can control anything is, well, I do it with a struct. It's basically like a state machine. You're switching, almost. You're just switching. Yeah, it's just a way of keeping track of stuff easily. If you see too many numbers on the screen, they don't mean anything. But if you can have the struct can be as descriptive as you want. Like like you've got command struct here. Instead of it just saying so and so equals 0 or 1, you can actually refer back to it. You know exactly where you are. Makes the code easier to read, basically. When you've got long lists like this command structure, these are all the different commands that that the packet system uses. And you'd soon lose yourself in it. There's all sorts of it. Lots of debug stuff as well. So anyway, let's go back to the other one again. So I wanted to just add to this. We're not going to stay too late today, because I've been on 4 hours already, 5 hours doing a video. So this one, we're going to go to something else. We'll try and make this into something, probably an example of what makes a good idea to implement, a way of implementing stuff. So we're controlling the serial print, and we can turn it off totally if we want. We just turn it off. We can just change this here to no debug. Just replace this part here with no debug, and then you can recompile it, and you'll end up with no debug. Yeah, these modern controllers, you can probably do JTAG and stuff. I've never used JTAG, so. But if you structure your code in such a way, the only thing that can really let you down is a library change or the wrong library. So it's a lot to be said for testing it. So at the minute, this is going to reset. If I just open this up, yeah. So we're resetting every 6 seconds at the minute, because we spoke about the millis going back to 0 once it gets to about 50 days. So I've implementing a way of doing it. So we're doing a way of doing it. So we're resetting it ourselves. Instead of waiting for the 50 days, we just put it on 6 seconds. But you could effectively program in the day before the 50 days, or monitor for the actual end of the 50 days. I'm not sure what the best way of doing it, because you could either do it once a week, once a night, or at some point. But you'd have to make sure if you're going to restart it, it's like someone pulling the rug from underneath someone's feet. You tip them over, so you don't want to tip the thing over. Sometimes you can use this in a safety system, and the last thing you want is to, halfway through some kind of safety system, is to pull the rug from under its feet. So you just need to be controlled way of doing it. Once your program gets big, like, where's it gone? Once it gets big like this, if I go into main, where's my main one? once it's doing its initialize setup parts, I split it up. I go do certain things at a time. You know, put my global variables in, and then I go serial print main setup, and you can go past certain stages. Because when you're trying to manage multiple platforms like this, a library can update, and then you'll end up they might have changed the code, or they might have tried to standardize their library and they've broken backward compatibility. So for no reason of your own, on your libraries here, if you're saying anything above, I think that's saying at that, I've got some that, yeah, that one there, anything above. So it could automatically update a library. I've got to sort these libraries out actually, because they're gone wild. Now apparently, I read into it, the library, did I do a chat GPT? Well, I asked it if the library would take up the extra space. I thought we could ask it that, couldn't we? I think I asked it already, I can't remember now. But supposedly, if you're not using part of the library, say if we open a library, I don't know if we can open these libraries from there. Yeah, so let's just go to a library. Yeah, we've already got a subject already. So go to a library. So here's your libraries for this one. Actually, we've only got them two there. So where's it getting the rest of the libraries? Is it these? I can't remember where they put them now. Oh, here they are. No. Where's all... Oh, libraries dependencies, yeah. Right, so yeah, there's all the libraries that are dependent for this particular platform. So if I go into, say, a touch screen, let's go into Adafruit touchscreen, for instance. Let's have a look at, not examples, actual library. So you've got your touchscreen CPP. Well, let's have a look at the header. Right, let's have a look what's in this header. I've never looked at this, but in this library, you've got a lot of extra stuff going on. Like most, if it's got this hash on it, it's conditional compile, so you're not going to really use more memory up. But if there's functions in there, if there's a function you're not using, there's a bit more memory taken up, and if they suddenly add a new function, they've decided I want to extend the library, I want a new function to do some certain thing, that new library is going to take up more space. But I suppose we could do an example. We could actually take a piece out. You'd have to analyse that when your program's finished compiling, how much memory it's using. Take a function out. They could always double. I tell you what, we could double a function, couldn't we? As a test. But I think the idea is that if you're not using a function, it doesn't take any more memory up. But there's a reason why the libraries are growing. Say on this platform IO here, if I go back to this node MCU here, I started life with the ability to do OTA, over the air updates. And as these, I haven't put any more libraries in, but I think they might have upgraded to a newer version. And all of a sudden, I haven't got enough memory left to compile the program with this over the air enabled. So I've had to put this little derivative directive in here. No OTA, CSV. So there must be a file. I don't know what that is. It must be a file to say don't bother with OTA, even though we've got async elegant OTA there. Still got the library, but it's so we can't do over the air with this particular compile because we run out of memory. Unless they've cleaned up their library. Maybe there was a rogue library with it wasn't properly contained or something. So what we'll do is, I'll tell you what, we'll switch over to this one. Node MCU. Right, that's the one there. So we'll switch over to that one. And I'll compile it with or without this, and I'll leave that in at the minute. We'll compile it and see if it'll compile. Just make sure we haven't broke it adding some other bits. Make sure it compiles. There's a lot of libraries in here. I mean, some libraries, when you add a library, there's some dependencies which get installed, like can't see it now. Oh yeah, this bus, Adafruit bus IO. I've not added that, and by adding something, one of these up here, it's added. It's probably that one. It's added these extras. Anyway, I'll just have a quick browse back again. Right. Okay. Right, so what I'll do now, we finish that, let's compile that. See if we can compile it. So have a look at the memory. It's not directly related to Arduino, but you need to look at your libraries ultimately. Trying to save space and memory space on the MCU. Suppose I should make a function that prints out the free memory with a library enabled or with it not. We could create two libraries and delete some of the stuff out of it, compile it for either one, and see what memory's left. Be nice if there was a way of live viewing the memory without affecting the performance of the program. Right, successfully created ESP32 image. Alright, still compiling. So it should compile this. This was a working this ESP32S node MCU is a working controller, so it should be able to do it. I think it's when I was using the screen. I haven't got all the switches switched on, so touchscreen and all that lot. Once you use touchscreen and TFT and touchscreen, there'll be more libraries added, so possibly it'll be alright in a minute while everything's not switched on. And this is quite slow today. It's always a bit slow. I mean, look at these ESP32 libraries. There's lots of stuff going on. Linking, right. So that's finished there. So what's it say about it? Right, RAM 16.6%, flash 57.2. So RAM, why is it showing me RAM? How does it know how much RAM we got left? RAM and flash, don't know. Right, so anyway, yeah, we're not using the OTA, so if I was to get rid of that, so we know what we've got there. We've got 16.6. Right, let's take this out. We'll cut that out. We'll save it and rebuild it with it out. see if there's any changes. Going off on a tangent really, hang on. Let's try and build that, see if there's any difference. It might not fail because we've switched, these switches are off for the touchscreen and the TFT. But let's see if there's a difference in the memory. Because that flag there tells what was there. In fact, I can just put it back now, can't I? No, I'll leave it. But that one there tells us that tells the system not to allocate space for the over the air. The copy of the program that you upload over the air, it has to store it before it in its entirety before it'll copy it over the main program area, Flash. So obviously if you want to free up the memory to use for other stuff, you have to put that in there to stop it using it. But then it depends on which controller you got, how much memory's in it. Some have got 8 meg, 4 meg flash and different size flash allocated in the table. I forget where you get to now. Somewhere down here, wasn't it? Oh, I'll just see what this does, then we'll get on with whatever we was doing. Get back to it. Yeah, it's quite annoying. It has to build everything back again. I can never understand why. I know we've made a major change by dropping that out, but why is it compiling existing libraries it's already compiled that we haven't touched? So there's something we've got to work out as well. It's wasting our time. Nothing's changed in that library, so right. Let's see if it's probably say exactly the same thing now. Yeah, let's have a look. 16.6 flash, 91% used. Right, so that's different. Can I get back up? Can I go right up to this, or has it cleared it? Right, so we've done. Let's have a look. Is it going to show me that, or is it too late? Right. Right. Yeah, so flash was 57%. 57.2% used. Same RAM is used. So I've took out. Yeah, do you know why? Because with this in here, if I just undo that, what the first time I compiled it was in there, and it was telling it not to reserve any memory for OTA. Well, this is interesting in itself, isn't it? Right. So don't reserve anything for over-the-air transfer, and then it's compiled it. Initially, it said it had used only 57.2% of the memory. So it tells you the actual bytes used: 11999841. Right. So then we took that out and recompiled it. So we were telling it it's going to try to reserve space for over-the-air transfer. So go back down here, and so that's almost the same size I've used with different amounts of free. So 91.5% is used from 131 bytes free. Let's go back to the other one again. Where is it? Yeah. So we've got some extra size here. So that's the same amount used. It says 57% is used. There's more space. So by telling it we don't want to use OTA, it's gave us more program space. 209 as opposed to 131. So it's basically give us quite a sizable chunk. But I didn't want to disable OTA. Didn't want to do it that way because I want to keep that ability in, of course. But I think it was just certain ones. Let's just save that. Yeah, which one was it that was causing us a problem? I think it's the Larlin. The one with the Larlin display, or it could be, actually it could be the watch. Could be the watch's TTGo3 T display V3. It's got the TFT touchscreen, everything else. Actually, no, they got more memory, haven't they? So that was okay because I haven't included that. Don't use the memory. So yeah, so the watches were okay. They must, I think they got some PS RAM or some, they got more flash size or something. More flash size. So let's find the one. Yeah, it's this Larlin here. So it's using the touchscreen and the the library for the graphics. The TFT. Is it using the TFT? Must be. Oh no, that's the Larlin D32 Pro, isn't it? Hang on, so which one was I using then? Right, hang on. So that's going back down to, it's not the 2 display. Could be the 2 display. It's touchscreen, TFT. It could be that one. Well, I think it's this one I've got down here. This Node MCU. Now, if I was to enable, I've turned off the touchscreen, haven't I? Here, let's have a look. As a touchscreen, yes. TFT, yes. NTP, yes. Wi-Fi comms, debug is off. It's not as simple, so right. As a Wi-Fi module now. Right. Right, okay, so let's just compile for that. Right, we'll take out this temporary. Save that. I'll switch over to, am I on Node MCU already? I'm already on it, aren't I? Yeah, I'm already on it. So we'll compile for that. It might not be able to do it now because there might not be enough memory. I can't remember. Let's try it. Let's just try that and see what we get left. It might come up with an error, not enough memory. There was a reason I had to put that in, but whether it was a rogue library and they've tidied it up since. Oh yeah, what's this? No, I've got an error anyway. What's this? OLED debug. So we've got an OLED. Hang on. Right, so yeah, we can always have an OLED. Right, I've got an extra problem here somewhere. Right, commands was not declared, so right, I've got to declare that. 1391 in commands. Let's sort that out. This is going off on a bit of a tangent, this one, isn't it? Alright, keep going. Let's use the scroll bar. Right, 13. Right, 139. Here it is. Right, so if it has a OLED, right, so it doesn't know anything about that, does it? Right, so Commands H. Right, let's have a look. So as right, okay. So go back to there. Right, an OLED. Hang on, OLED. Right, so I've not told you about, hang on. Right, OLED debug receive string, right, Can't remember where that goes now. Right. That should be on an OLED, shouldn't it? Right. Yeah, because it uses different... Let's find the OLED controls. Where is it? Display OLED here. Right. So it's saying it's missing OLED debug receive string. Right, yeah, because I've added bits to different parts, but I've not gone ahead and done it everywhere. So I'll get back onto the OLED debug receive string. So it says it's got it there. If it has an OLED, yeah. Right, what's probably happened, I've not included it in here. So if we've got an OLED, right, debug receive string, yeah. So it's there. So it is there, but maybe I've just not declared it. So it's saying use this, but I've not told it where it is. It's not including the OLED. Right, let's find out why we're not including an OLED. What we got here? So we're including... where's displays? Display TFT. Alright, so not actually including it in there. Right, so update feedback. Find all references. This could be just a local file that OLED debugs. Yeah, it's in the OLED screen, so it's not finding it. Didn't find anything. Right, OLED debug. Finding files. Let's do finding files. Right, so we've got one in OLED there. We've got one in source, so it's definitely there. But we're not including the display. We're saying it's got an OLED, but we're not including it. Alright. So let's find the one over here. So that's the one there. And we've... Oh, where's that? That's display OLED. There's the routine for it. So it has got it, but for some reason it's been filtered out. Has an OLED is one, then include this. Yeah. So we've got that there. So it is there. We can't find it. And what's the reason it can't find it? Because... Let's have a look. Oh, let's go to the top of it. So it's including Command H, that's all it's doing. Oh yeah. If it's got a TFT external, we haven't told it it's external, have we? Hang on. Let's go back here. Have I included external void? Yeah, we need to just put that in there, don't we? It's looking for an external thing, but so right. So let's just do that. That should be easy enough to do. So we'll go back to this. We'll copy go back down to our error. Where's it gone? There. I'll copy this bit here. Actually, you could probably copy the whole thing. Then we go to Command H. TFT, let's just put another one in here. Right, so if it's got an OLED, let's do an external void. Like that. That should be enough. Right, let's save that. Let's do another compile. And see if it'll like it now. Yeah, probably because I've never switched a TFT and an OLED on at the same time. Or, no, we've got more errors. Dear. What, we got errors on there? Declared void. Oh. Right, maybe it isn't void. Right, let's have a look. OLED. Oh yeah, void. It is void. So, command variable field declared void, external void. Message was not declared in this scope. Right, didn't like something about that. Oh, didn't like the message. Right, I know what I've got to do. I've got to tell you what it is. I've got to go back to OLED H and just copy this bit here. I've got to put that in. I've got to put that in there. Right, that's it. Yeah, that's it. It's got to match. Right, is it anything else it's going to fail on? Right, let's just have a quick look at what's going on over here. Nothing. Okay. Right, so yeah, we're compiling that. So, anyway, it's talking about OTA. And we're using an ESP32 S3. So, it's not exactly not relevant, it's slightly relevant. Yeah. Right, is it going to compile this time or is it going to complain again? Because it's possible to have an OLED, an LCD display and a TFT screen all in one. I've done it. You just don't plug it in. There's no inputs off them. They're just, they'll write into the registers. If they don't exist, then it doesn't really matter. It'll just use the memory and think it's there when it isn't. Maybe. I'm not sure if it might read back, and the library might get ignored if it can't find the device. Maybe. Right. Archiving and compiling. Right, what's it archiving? Why is it archiving? Don't know. Yeah, so if you've got multiple platforms, you've got to switch every switch on and off, and go through all the different switches for each platform, each controller, and then you've got to switch each parameter on and off as well. So very time consuming. Or you could just check your code, try and structure it better. Structure it so there's no chance of mistake, you know. The biggest problem is if you're running a shorter time and you've got to save it and carry on another day. What I normally do is put a mistake at the line I got to, put an invalid character or something, and then it'll take me straight to where I left off. Right, so it's compiled this time. Right, let's look at the memory. So we've used 96.1. Yeah, more memory we've used this time. Out of yeah, so we haven't run out of memory for the Pro. We almost run out. Look at that. So yeah, we've almost run out. Let's go back to platforming. We'll just put that back. No, that's not what we want. Hang on. Let's find the right code for it. Where has it gone? Oh, there you go. I'm going the wrong way. Trust me, I can't find it now. Here it is. Right, let's go and copy that back down into here. I'll just... Right. Right, so we don't want OTA, but we could still do OTA at the minute. That's back where it was anyway, so I'll save that. So maybe the library, one of the libraries was doing it and we're okay now. I don't know. But we're compiling for a node MCU, so surely it knows what memory it's got left. Anyway, we'll leave that for now. Maybe it's when I put the debug on. Yeah, I'll tell you what, I'll put the debug on. And that's probably where it's going to fall down. It won't have the memory to do all the debug, not with being 96% complete. So that's why. So there, I'll just take that out again. Save it. Right, well, we've just switched the debug on. Let's see if it'll compile now. See how much memory it's got left. Well, this is the last time we'll do this now. Yeah, I'm sure there's a way of getting not to compile the stuff it's already compiled. I thought I did that. Or did I? Was it in another program? You can tell it, there's something you can switch that it doesn't go and keep compiling the same stuff. You only want to compile the bits that the bits you've changed, really. Let's log on to ChatGPT, see if it knows anything. If I can. Alright, let's get another one of these up. ChatGPT, see if it'll let me on today. How can I help today? Yeah, that's fine. Right, I've just got to go on to bookmarks. Right. Okay, so while that's compiling, let's is it finished? Yeah, it's doing all this lot. Successfully created an ESP32 image, so why is it carrying on then? Archiving. Oh, it's compiling an archive. I don't know what it's doing. Must have separate images. Yeah. Yeah, I've got no control over these libraries. Look at all this lot. I'd love to just create a new library with the bits you're using. Just, I don't know. Anyway, let's ask ChatGPT a few questions in a minute. By all means, we shall ask it a few questions. Let's get the when this is finished, hurry up. Oh my god, look at it. An MD5 builder. Stream, CPP. Yeah, there's a lot going on. I suppose it's struggling when I'm streaming. What I'd probably need to do is output HDMI off the computer and use a separate computer for the streaming, and then compile on a computer that's not streaming. Right, let's have a look here. Right, so we've got still 96%. So I think we're using more memory than we did last time there. But it still hasn't run out, has it? It hasn't refused to do it. So it's 1266. Let's find the other one. 1, 2. Yeah, so it's still. Yeah, so it hasn't run out yet, but we've only got 131. So when that figure gets to that, it's gonna refuse to do anything with it. So yeah, it hasn't run out yet. So I know what I've done. What I've done is I've cleaned up an area which has freed up some space. It's freed up some code. This HTML here, yeah, because I was compiling this to the Flash, which is the same as the program space. This CSS here, all this lot here, all this, all the way down to there. Keep going. All that, right to there, was going into Flash. Well, it was going in on every part of the program, so it was going into the engine. It was in here at the front, a duplicate of it, and it was in here on the settings, and it was here on the about as well, and the login as well, and the about. So I'd got 4 lots of the same CSS, but I've changed the way it does it now. I've put this in there. See that style sheet? I've added that into the code, and it's looking for this engine CSS. Now it's able to pull that in without any problems, which normally on an HTML web page you can, but when you controllers, I'll try to it'll do it, but because it's part of the CSS, but you try to add a header of HTML code, it won't. I can't get it to go. So anyway, that's why I've got loads of space left. So that's good news, actually. I'd realised I'd forgot about that OTA, and I probably don't need that command in there anymore to turn it off. So that's good news. That means I can do over-the-air update again. Right. Okay. That's something to be aware of. Right. Okay. So let's put all this back where it was. Undo that. Save it. Right. Shall we push it? Might as well push it. Commit. Where we can't spell today. Commit, and we've debugged part of it, and I'll just say OTA. Bit of work on the OTA. Alright, push. Right, so come out of this now. Alright, come out of that. We're back on this again. Right, let's ask a few questions. So we're on ChatGPT now. Oh, let's sit up. Right. ChatGPT. So I had 2 questions for it, and I can't remember what the questions were now. But hi Dave, what are you gonna do? Can you shortly explain? I could. I'll just. I would, but I am winging it here. Yeah. Yeah. Okay. It's not really winging it, but yeah. Right, so we're on ChatGPT. Now I've got certain things I need to ask it. Right. Right. Do Arduino library functions. I've asked this before, I'm sure I've take up flash space. Hang on. Let's just reword that. Do unused library functions take up flash space on ESP32. Let's see if it understands what I'm trying to ask it. I'm not asking it in a very good way. Yes, unused library functions in an Arduino project for an ESP can contribute to the overall size of the compiled binary, including the flash space. When you include a library in your Arduino sketch, the compiler includes all the functions and code associated with that library in the final binary, regardless of whether you use all of them or not. Well, they are. To reduce the size of your binary and save flash space, you can consider the following strategies. Selective inclusion. Only include the libraries and functions that you actually use in your code. Remove any unnecessary libraries from your sketch. Yeah. Library alternatives. If a library has more features than you need, see if there are alternative libraries with a smaller footprint that still meet your requirements. Custom build. Some libraries allow you to configure them during the build process to include only the specific features you need. Check the documentation of the libraries that you are using to see if this is possible. Code optimization. Optimize your code to be more efficient. Sometimes a more optimized algorithm or implementation can reduce the overall size of code. Keep in mind that the ESP32 has a generous amount of flash space compared to some other microcontrollers. But if your project is reaching the limits, optimizing the code and being selective about libraries can help manage the available resources more efficiently. Yeah. So I think I'm going to have to create a custom library, or at least, yeah. And the trouble is, how do you create a custom library and then keep up to date with any bug fixes or updates from those libraries? You can't. You'll have to manually copy and paste. That's not good. So you've got to include that whole library, even if you don't want. You might have a load of graphic routines that draw into a TFT screen, and you're only using a couple. It's just wasting your space. I suppose it doesn't matter if it takes longer to compile, longer to upload, and if you're getting close to your limit, you'll have to turn off some of your features just to include some library code that isn't being used. So this is a bit of a problem. But why doesn't your compiler analyze what functions you're using and don't bother to compile them? It's literally going with the header. If the header tells it it's there, then it finds it and compiles it. We'll have to do a test. But this is saying that right, so that was the one question we've asked again. We've had it answered. Now there was another one. Can't think of the other one now. Right. Let's have a look here. See if it brings anything up. Right, is this gonna... Oh yeah, the best course of action. I think I asked it that yesterday. Right, let's go back to ChatGPT. Oh, I think I asked this. Right, so the Arduino core Millis rolls over after about 50 days. What is the best course of action best course of action to prevent roll over problems. Right, let's see what it can do with this. The Millis function in the Arduino core. Right, okay. I think I might have asked this already. Oh, 1 minute. Right. The Millis function in the Arduino core uses an unsigned long data type to store the milliseconds since the program started. As an unsigned long can represent values from 0 to whatever that is, 4,294 million. So and so. It will roll over to 0 after approximately 50 days. You continue to run your Arduino sketch. To prevent rollover problems, you can use the following techniques. Yes, that's what we want to know. Millis reset check. Periodically reset your system or perform a check to see if Millis has rolled over. If the difference between the current Millis value and the previous one is negative, it means a rollover has occurred. Okay. So unsigned long, previous milli, right, so if current Millis minus previous Millis is greater or equal to interval, reset or take necessary actions. Previous Millis equals current Millis, right. Reset to take, that's not reset nothing. Oh, reset or take necessary, or reset the controller, that's what it means, yeah. Use Millis for time differences. When comparing time intervals, always calculate the time difference using subtraction. This accounts for rollover automatically. Okay, what's this then? Right, let's see what we're doing here. So unsigned long, duration 1 minute. Unsigned long, current Millis. If current Millis minus the start Millis is greater than or equal to the duration, time interval has passed. Okay. By using these techniques, you can mitigate rollover issues, ensure that your timing related code continues to work reliably even after long periods of operation. Keep in mind that these approaches assume your Arduino board remains powered on during the entire period. If your board is subject to resets or power cycles, additional considerations may be required. So when comparing time interval, always calculate the time difference using subtraction. This accounts for a rollover automatically, right. Subtraction, let's see what I'm doing. How did I do it? Did I do it with subtraction? Let's have a look. Alright, so execute the function. If start millis plus execute millis is less than millis, so I didn't do it with subtraction. So I got the start millis, which was 0. It could be the last millis plus the timeout is less than. I'll tell you what. Let's give it the code. Let's give. It's not going to know what them other things are, but anyway, let's give it this code. We'll give this the code. Give. Can I paste an example code? Right, okay. Okay, it looks like you're providing example code that uses a timeout mechanism to execute a function. Periodically, the code also includes a check for restarting after 6 seconds. Oops, where you gone? However, there's a potential issue in the comparison. Execute start millis plus execute now timeout is less than millis, since millis is an unsigned long. If execute start millis plus execute now timeout wraps around due to rollover, the comparison might not work as expected. To address this, you can modify the condition to handle rollover correctly. Okay. Let's change that then. This modification ensures that the comparison considers rollover correctly by subtracting execute start millis from millis. Here's the modified code. Right, let's just put that in there then. Sounds good to me. Sounds good to me. Let's just let's try it. Should be fine, I would have thought. Right, let's try it. Let's change this code here for the code that he's just given us. Right, let's compile that. So, will it still execute every second? And then, yeah, see if it does. Compiling this sketch, so that's going to take a little while, isn't it? Let's go and thank. Let's go and thank ChatGPT. TNX, see if it knows what TNX. Thanks, ChatGPT. So does it know what TNX is? You're welcome. If you have any more questions or there's anything else I can help, feel free to ask. Happy coding. Happy coding. Let's see if it knows a joke. Can you tell me a joke? See if it knows any jokes. Sure, here's a joke for you. Why don't scientists trust atoms? Because they make up everything. That's funny. Can you tell me an Arduino joke? See if it can make an Arduino joke. Certainly is an Arduino related joke for you. What? Why did the Arduino go to therapy? It had too many issues with commitments to loops. I don't get that. It's a bit too clever for me. Another, please. Another, please. See if it gives another joke. Why did the Arduino bring a ladder to the sketch? because it wanted to reach the high level code. Oh my god. Can you make it cheesy? Absolutely. Let's add some extra cheese. Why did the Arduino go on a date with a resistor? Because it heard that they had great resistance to breaking up, and they wanted a connection that was so special. Oh my god. Right, okay. Actually, I could type in a poem I created at school and get it to try to improve it. I'll try that in a minute. I'm going off on a tangent again, aren't I? Right, it's finished compiling. Didn't see any errors, so let's upload it and see if we still get a working system. Should do. It wouldn't tell me a bit of code that's not quite right, would it? I haven't even looked at it properly. It's basically getting the millis first and minusing the start millis, and if it's greater than or equal to the execute timeout. Right, I see what it's doing, yeah. Right, let's just see if it's doing it. Right, so it's counting up to, and it should, do a reset. So it's doing the same thing, but it'll be better for rolling over, yeah. Right, I've got one more question for ChatGPT. Let's ask it something. Can millis be written to? Probably not. It's a read only, I would have thought. Yes, millis can be written to. The millis function in Arduino returns the number of milliseconds since the Arduino started running the current program. If it is a read-only function, meaning you cannot directly let you write to it. So right. The millis function relies on the internal timer of the microcontroller. Its value is automatically updated by the Arduino runtime. It's designed to provide a convenient way to measure elapsed time in your sketches. If you need to create a custom timer that you can control and reset, you might want to use a variable to store your own elapsed time. Here's an example. Right, so custom timer, yeah. So you don't have to use millis, but you'd have to keep a track on your own time. So your intervals every second. If your millis minus the custom timer is set for you to check if the custom timer has reached the interval, do something. Custom timers millis, reset the timer. Yeah. So if you're doing it every second anyway, which we are, you could update. You could check. Yeah, but it's not. You could increment your own one every second, but no, I don't know. Yeah, right. Let's give it a code. Can you make? Hang on. Improve my poem. Certainly, I'd be happy to help. Right, okay. The mystery of this poem is the magic that it holds. The magic that it holds is consumed in a cell. The cell is in a world. Cell is in a world of growing people. And whom, how do you spell whom? Don't know how to spell. Whomever tells on hiding place will be magicked away. Right, let's see what it does with that. Probably got it wrong. I'm trying to remember it from 40 odd years ago. 45 years ago. Right, so here's a revised version. In the mystique of the verse, enchantment unfolds. Okay. A magic confined within a clandestine hold. Okay. This mystical power resides in a secluded cell. A realm within a world where life stories swell. In this domain of burgeoning souls and dreams, whispers echoes unveiling secrets in streams. Yet beware, for those who reveal a hidden space shall be spirited away by enchantment's embrace. ChatGPT, eh? Can you do it keeping the original wording? Certainly, while preserving your original wording is a refined version. The mystery within this poem, a captivating lore, holds a magic bound in a mystical core. Oh my god. It's gone above its remit here, hasn't it? The enchantment encased within a hidden cell thrives in a world where growing stories dwell. Imagine if I put that into the English teacher back in the day. They'd probably thought I was after their job. Within this realm of evolving souls and grace, whoever reveals a secret hidden place shall be spirited away by a magical sway, as the mystic essence guards its hidden bay. You are actually, this AI is actually insane. Did you know? Well, I don't even know if you could even say it. Shall I ask it? Are you sane? How do you spell sane? Don't know. I don't possess feelings, consciousness or sanity as humans do. I am a machine learning model created by an open AI. Yeah. I'm here to provide information, answers questions and assist you in the best way. If you have any concerns or questions, feel free to let me know, and I'll do my best to help. And stop having a go at me. That's what, you know. Oh, it's got no feelings, yeah. Okay. Right, what else can we tell it? What else can we tell it? What should we tell it? I don't know. I wonder if it could improve my website for me. Can you improve my website for me? I'd be happy to provide guidance and suggestions to help you improve your website. However, please note that I can't directly access or modify your website. Yeah. Yeah, I think I've already asked it about port stuff. Right, anyway, let's say goodbye. Thank you for your help. Much appreciated. Appreciated. See you soon. Not really. You're very welcome. If you ever have more questions or need assistance, feel free to reach you. See you soon and happy coding. Happy coding. Right, that'll do. Right, close that one. So, where did we get to? We're still streaming and we've been an hour and 20 minutes. Let's see if there's anyone out there. Are they all sensible people in bed? Yeah. All sensible people in bed. Anyway, that's going to about do it for today. So, what did we learn today? We learned to change our millis to subtract it instead of additioning to avoid any problems in the future. That's all we managed to learn today on that, and we also asked ChatGPT a few things, and we learned a little bit about OTA, over the air, and because I cleaned my HTML embedded in the program memory code, we freed up some flash space for we can actually use OTA now. Yeah, we can use OTA again. So anyway, that's going to be it for today. Thanks for watching, and we'll see you all again in the next one. Bye for now. Turn your headphones down. See you in a bit. Bye bye.